Here we are again, my good people. Today we're gonna have a small experiment. I've been asked about the current, the output current or power for this little boost converter, and this is LCBST. I have some reviews about this guy. This one goes up to 28 volts, I recall, and some people are concerned about how much power or current, in fact, this guy can deliver. So let's do a little experiment today. This is the output and this is the input, the battery input. Instead of a battery, I'll use my power supply because it's easier to see the currents. Chip 83, and we have a 5 amp. Orange is plus. We have to be real careful because I'm not sure it have any protection for reverse polarity. We'll check that after. Here we go. This is plus, this is minus. We should have a working device now. Obviously, there is no current here because the standby current 180 microamps. Okay, but we can check the voltage. 28 volts. Obviously, this is too much for this little guy, but let's try. There we go. Amazing. It's struggling, but it's amazing. It's delivering. Let's get my ammeter in series. All right, it's going down like 280 milliamps at 28 volts. That's not bad at all. So I bet. Okay, we are in short now. 4 amps. Are you kidding me? Is there? Okay, I'm afraid it smells. So let's forget about this. Once again. I believe it's gone. So my dear people, it's just gone. What? 1.8 volts. It smells bad. So don't even think about having a supply like this, and supply this boost converter with such a high current like I did. Anyway, but as long as we are here, let's see what's happening if we just reverse the polarity, okay? Is it burning? Okay, reverse polarity. Test on. Oh yes, 5 amps went into the module. Look at my power supply. 5 amps. And it's burning. Look there. Yes. The magic smoke is out. So don't try reverse polarity because it's gone. You just burn it. All right, a new one. What we find out so far? Don't reverse polarity. It's burning in few seconds. Perfect. So this is gone. The first victim of the test. All right, orange is plus. We'll do the same connection here. 5 volts. Okay, let's try to have this bulbs. But first, let me check for. So it's a 4.9 ohms. It's a really huge load. It's like 20 watts or something, maybe more. All right, let's try with this one. Remember, almost 5 ohms. Let's go to current. 230 milliamps, 0.23 amps. And it's not even getting 5.52 volts. Nice. Guys, I was thinking what else can I connect here? So this is like 24 volts, 0.14 amps, 140 milliamps. Let's see if it's enough juice from this guy to move or to spin, in fact, the fan. Okay, we are on 6 volts. And amazing. It's just running, and it takes 60 milliamps. Let's raise the input a little. Let's take a full charge 3.92. That's okay. Let's have a higher voltage. $28 and it's taking 1.86 amps, kind of hot. 1.82 amps. Yeah, it's working. So this is the maximum voltage output, and we have around 27.5 volts, and without the fan we have let's see, 28.6, 1.1 volt difference. And let's see the output in amps. (0.16 amps, 160 milliamps, and it's taking 1.77 amps from the power supply. Okay, let's go like this and check for the temperature. Let it run for a few minutes. Is this guy here passing 100 degrees? It's this little guy here. You see? The little circuit down here. It goes up to 105. Yeah, we got the temperature there. Okay, very clear. But you see? Okay, so that little guy over there, it's passing 100 degrees, but it's still running great. And you see the power consumption, 1.64 amps. It's getting higher when the fan is blocked or relatively blocked. 1.15. Let's see. Oh yeah, this is so mad hot. You know something? That's the little circuit here, the one who needs a little bit of cooling. You see, people, this is the circuit responsible for boosting the voltage. So this one here can be easily cooled down with a little pad or some aluminium. How can I improvise something like that? A little temperature radiator. So it's kind of delivering 0.16 amps without a problem. Even if it's getting hot, I really don't know how long, but you see a pad like that can help for cooling down. That can be easily done like this. Oh yeah, I can feel the heat already. Yeah, of course. Well, probably a small aluminium heatsink will help. We have this guy now delivering relatively high current for a longer period. Anyway, it's working. So I don't want to push it too much, but as you can see, it delivers 0.16 amps and the voltage drop it's 1.1. Now I don't want to think about getting down to 9 volts for supplying a multimeter, and that's piece of cake. So this guy can deliver. All right, rules: don't, or at least try not to reverse the polarity. You saw that it was burning. Okay, so even the temperature is getting so high, more than 100 degrees. I think a small aluminium heatsink will help this for delivering longer period of relatively high current. Okay, it went down to 1.3. Why? Does it? Oh, it's burning. I'll improvise a heatsink in a future video, and let's see if we can improve that. But anyway, to power a multimeter, that's a piece of cake. That's it for today. Don't forget to subscribe to my channel. I'm waiting your comments, of course, and like usually, have fun. Bye bye.